We are beginning a new topic today, and it's on bearing and vectors. What are the objectives that we look forward to achieving at the end of this topic? At the end of this topic, you should be able to solve distance bearing problems. You should be able to add, subtract, and multiply vectors. You should be able to find the magnitude and direction of a column vector. And you should be able to understand and use the triangular law of vector addition. Don't worry if you don't understand most of the terms here. I'm going to explain all of them to you. Let's begin by tackling the first part of our topic, which is bearings. Bearings give direction in terms of an angle. In our everyday lives, we use directions. When we are moving from one place to another and we do not know the place we are going to, we ask people for directions. Vehicle drivers, pilots, and captains of ships also use directions in order to navigate from one place to the other. In the directions that we give to people or people give to us in everyday lives, we use some points as our point of reference. Now this is what I'm talking about. Let's say that we have this town here called town A, and we are going to represent town A with this circle. There is a 3 here, and there's another town here called town B. Now, Mr. Kofi, we are going to call this man here Mr. Kofi. He's at town A, and he wants direction to town B. Since he's already walking in the direction of the tree, if he asks you for directions to town B, what will you tell him? You might probably tell him to walk straight to the tree. So he will walk straight to the tree here. Then when he gets to the tree, you will tell him to turn left and walk straight. He will be able to get to town B. So he will turn left and walk straight to town B. So you have been able to give Mr. Kofi direction from town A to town B. These are the directions that we give to people in our everyday lives. So you see the path that Mr. Kofi will walk through will be from town A to the tree, then from the tree to town B. This is the path that Mr. Kofi will take in order to get to town B. These are the types of directions that we give to people in our everyday lives. Bearings can also give direction, or bearings also give direction. But for bearings, the direction they will give will be in terms of an angle. Now, this is what we are talking about. Let's say that we want to give Mr. Kofi direction from town A to town B using bearing. How do we do it? All we need to do is to draw our 4 cardinal points on town A. We know our 4 cardinal points from GHS. That is north, then here will be south, here will be west, and here is east. So these are our 4 cardinal points on town A. So Mr. Kofi is at town A, and these are our 4 cardinal points. What we will need to know is the angle that Mr. Kofi will have to turn when he is at town A. Now this is what we mean. You can see that when you draw your 4 cardinal points on town A, you can draw a line from town A to town B. Now, if we give Mr. Kofi this angle here, the angle that will be created here, if we give that angle to Mr. Kofi, all Mr. Kofi needs to do is that when he gets to town A, he will turn in this angle. He will turn using this angle. So let's say that the angle we are going to give, or the angle form here, is 70 degrees. Okay. So all Mr. Kofi will need to do is that when he gets to town A, he will face in the northern direction, that is this direction, then turn 70 degrees towards the east. When he turns 70 degrees towards the east, he is going to be on this line. Then he will now begin to walk on this line, and he will get to town B. So from here, we can say that when Mr. Kofi gets to town A, this time he stands on town A. Instead of walking straight to the tree, then turning left in order to get to town B, all he needs to do is that he will have to turn through the angle that will be given to him. Here we are assuming that the angle is 70 degrees. So when he gets to town A, he would face the northern direction. So here Mr. Kofi is going to face in the northern direction like this. Then he would turn 70 degrees towards the east, as we saw in the diagram, as we saw previously, and move along that line. So as soon as Mr. Kofi turns 70 degrees towards the east, he will begin to move along that line, and he can now move from town A to town B. So you see, we have given directions, but we gave directions in two types. In the first one, we use the tree as our reference point. So he walks from town A to the tree, then turns left and walks to town B. But in the second one, we used as an angle to give the direction. This is what we refer to as a bearing. When you use an angle to give direction, we call that angle the bearing. So in this case, the angle that will be created here, this angle, the one we assumed as 70 degrees, let's take it that is 70 degrees. The angle that will be created here is called the bearing of town B from town A. So the angle that is used to give the direction is what we refer to as the bearing. Because here we are giving the bearing of town B from town A, this 70 degrees here, we are just assuming the angle that will be created here, which we are calling 70 degrees, is referred to as the bearing of town B from town A. So bearings gives directions in terms of angles. I hope that is clear by now. Let's move on. Bearings can be written in two forms. The first one is the compass bearing, and the second one is the three-figure bearing. In these videos that we are going to watch, I will explain the compass bearings and the three-figure bearings into details. So in this particular video, what we have been able to see is that bearings give direction in terms of angles. So whenever you use an angle to give direction to a certain point, we call that angle the bearing. We have also seen that bearings can be written in two forms, that is the compass bearing and the three-figure bearing. In the subsequent videos, we are going to learn more about the compass bearing and the three-figure bearing and how to represent these bearings on a diagram. Compass bearings are based on the four main cardinal points. The four main cardinal points are north, south, east, and west. So in writing compass bearings, we use these four main cardinal points. We use the letter N to represent north, the letter S to represent south, and the letter E to represent east, the letter W to represent west. These are the points used in compass bearings. Examples are N 70 degrees W and S 10 degrees E. So N 70 degrees W is read as north 70 degrees west, and S 10 degrees E is read as south 10 degrees east. So where you see N, it means north, W means west, S means south, and E means east. How do we represent these bearings on diagrams? The angles, in representing these bearings on diagrams, the angles are measured either from the north or the south. This information is very, very important. We are going to use it as we learn how to represent compass bearings on diagrams. Let's take some examples. Represent the following graphically, or represent the following on diagrams. And we have been given 4 questions here. We will take them one after the other and solve it. So we will take the first question. North 60 degrees east. North 60 degrees east. How do we represent this on the diagram? Now, when you are given the question like this, the first letter gives you an indication of where you have to start. Then the second letter gives you an indication of the direction in which you have to move. So the first one is north, which means that we are starting from the north. Then the next one is east, which means that we are moving towards the east. So in this case, we'll be moving from the north in this direction towards the east. The angle gives you the angle in which the angle gives you the angle which you are supposed to turn. So we are starting from the north, we are moving towards the east, and we are supposed to turn 60 degrees. Don't forget that between the north and the east, the total angle there is 90 degrees. So the total angle there, the total angle between the north and the east is 90 degrees, and we are supposed to turn 60 degrees. So total angle between north and east is 90 degrees. Total angle between south and east is 90 degrees. Total angle between south and west is 90 degrees. And total angle between north and west is also 90 degrees. Okay, so if you are clear on that, let's move on. So we are measuring from the north towards the east, and we are moving, or we are turning 60 degrees. So that is what you do. You draw a small arc, or an arc that represents 60 degrees, then you draw a line through it. So you draw a line from the center passing through the tip of the arc, and you indicate that by an arrow. Then you write the name of the angle here. So we have been able to represent this bearing north 60 degrees east on a diagram. Let's move on to the next one. North 85 degrees west. So as I said, the first one gives you an indication of where you are starting from. So we are starting from the north. The next one gives you an indication of where you are supposed to move towards. We are starting from the north and we are moving towards the west. So it means that in this bearing, you will be moving in this direction from the north towards the west. Okay. Now, the angle gives you an indication of how much you are supposed to turn. So we are moving from the north towards the west and we are turning 80 degrees. Once again, between the north and the west, the total angle there is, sorry, we are turning 85 degrees. Between the north and the west, the total angle there is 90 degrees. So 85 degrees will be something close to the west since it's getting closer to 90 degrees. So you draw your arc from the north in towards the west and you make sure that it represents 85 degrees since you will not be drawing it to scale. So after you are done with that, you draw a line through it as we can see from here. Then you indicate on the line, you write this arrow on the line to indicate that this is the bearing. So we have 85 degrees, which is the name of the angle or the value of the angle that you write it there to indicate that one also. We move on to the next one. The next one is south 45 degrees west. So this means that we are starting from the south and we are moving towards the west. So in this bearing too, it means that our angle will be moving in this direction. So we move from the south towards the west. Okay, so let's move on. And we are supposed to turn 45 degrees. Now 45 degrees is half of 90 degrees. So you make sure that your arc that you draw represents half of the total angles here. Since between the south and the west, the total angle there is 90 degrees. So the arc should represent something about half. Okay, after you are done with that, you draw your line through here and you indicate the arrow sign on it. Don't forget to write the name of the angle there. Let's consider the last example. We have south 10 degrees east. So this one also means that we are beginning from the south and we are moving towards the east. So we'll be moving in this direction. So from the south towards the east. And we are supposed to turn 10 degrees. So from the south, we turn 10 degrees. Since 10 degrees is very small, you see that I've drawn a very small arrow. Then you draw the line through it like this. You indicate your arrow here. then 10 degrees, you indicate your 10 degrees here. So since 10 degrees was small, I drew a small arc. Then from there, you draw your arrow and you indicate the name of the angle on it like this. So you see, it's very, very simple when representing compass bearings on diagrams. The first cardinal point gives you an indication of where to start from. So you see that it's either the north or the west or the south. That's why the point was telling us that we measure the angles from the north or the south. The second cardinal point, which will be the west or east, gives you an indication of where to turn. And the angle also tells you the amount that you are supposed to turn. So here we are supposed to turn 10 degrees. So you turn from the south 10 degrees towards the east. In a 3-point bearing, the angles are measured in the clockwise direction from the geographic north. We learned in the previous video that for compass bearings, the angles are measured either from the north or the south, and the direction in which you measure the angle depends whether the other cardinal point is the west or the east. For 3-point bearings, the angles are always measured from the geographic north in the clockwise direction. Now, we saw from the previous video that when we draw our diagram this way, this point here is the geographic north or the north. For 3-point bearings, the angles are always measured from the north, and they are always measured in the clockwise direction. So for 3-point bearings, the angles are always measured from this north in this direction. So we always measure the angles in clockwise direction from the north. What you have to know about 3-point bearings is that the north usually picks, beginning from the north, the angle there is 0. So the angle from this at this place is 0. We learned in the previous video that between the north and this side is 90 degrees. So from 0, when you move in a clockwise direction to this point, is 90 degrees. Moving from this point to this point is another 90 degrees. So when you add it to it, you get 180 degrees. Now from this point to this point is also another 90 degrees. So you add it to 180 degrees and you get 270 degrees. From this point here, which is 270 degrees, back to the north will be another 90 degrees. So when you add it, that will be 360 degrees. These values are very, very important. You need to know them because you are going to use them a lot in our studies on bearings. The angles in 3-point bearings are usually written using 3 digits. Let's pick some examples and see how to represent 3-point bearings on diagrams. So the first example, represent the following graphically or represent the following on diagrams. We have 4 questions here. We will take them one after the other and solve it. So we pick the first one, which is 6060 degrees. Because 3-point bearings are written in 3 digits, 60 degrees will be written as 060. So when you see 060, it's the same as 60 degrees. We have learned that to represent 3-point bearings on diagrams, we measure the angle from the geographic north, which is this side, in the clockwise direction. So the angle gives us an indication of how much we are supposed to turn. Here, the angle given us is 60 degrees. So it means that we are supposed to turn 60 degrees from this north in the clockwise direction. So we are supposed to turn 60 degrees in this direction. Okay, and that is exactly what you are going to do. So you draw an arc that represents 60 degrees. Once again, between this side and this side is 90 degrees. So make sure that 60 degrees represents something that looks like 60 degrees. It should be more than half. Your 60 degrees shouldn't be too small and it shouldn't be too big too. Okay, so after you've done that, you draw the line through it as we did for compass bearings, and you indicate the angle there. So the angle there is 60 degrees. Very, very simple. Let's look at the next one. The next one is 112 degrees. 112 degrees. Once again, for 3-point bearings, the angles are always measured in the clockwise direction from the geographic north. So here is the geographic north. So for 112 degrees, you'll be measuring it from this line here in this direction. So you are going to measure 112 degrees in this direction from this line here, from the zero line. Okay, now let's begin. We know that from 0 to this point here is 90, but the angle we are looking for or we are measuring is 112 degrees, which means that 112 degrees will be in this quadrant, will be in this zone, this area. So it will be between 90 degrees and 180 degrees, because when we move from here up to this point here, it's 90 degrees, but we are looking for 112 degrees. So it will be within this area. So we need to measure the angle left. What will be left in order to get 112 degrees? And to do that, it's very, very simple. We subtract 90 degrees from this angle that has been given to us. So it's going to be 112 degrees minus 90 degrees, and that is going to give us 22 degrees. What that means is that if we add 22 degrees to 90 degrees, you are going to get 112 degrees. The reason being that when we move from this side to this side, we are at 90 degrees, but we are looking for 112 degrees. So if we want the angle left, we subtract this 90 degrees from 112 degrees, and we just found out that that is 22 degrees. So it means that we have to measure 22 degrees from this 90 degrees, not from here, from 90 degrees. So we measure 22 degrees from 90 degrees. So you draw something small here, we draw our line through it, then we indicate that this is 22 degrees. So in actual sense, we have actually measured from this line here up to this point, which is 112 degrees. But because we are looking for this angle, we are going to indicate this as 22 degrees, because if you add 22 degrees to 90 degrees, we are going to get 112 degrees, which was given to us. I hope that is clear. So we add 22 degrees to 90 degrees. You remember how we got the 22 degrees. 112 degrees minus 90 degrees will give us 22 degrees, which means that we have to add this 22 degrees to 90 degrees in order to get the 112 degrees. So we have been able to represent this angle on the diagram. Let's consider the next question. 192 degrees. 192 degrees. Once again, don't forget that we are always measuring from the geographic north, which is this point, in the clockwise direction. So from the north in the clockwise direction. Okay, now let's do that. So if you are measuring from the north in the clockwise direction, it means that you move from 0 to this side is 90 degrees. We are looking for 192 degrees, so that will not be enough. We move from 90 to this side is 180 degrees. We are still looking for 192 degrees, so it means that that will not be enough. But looking at 192 degrees, you can see that it's between 180 degrees and 270 degrees, which means that you have to add something to 180 degrees in order to get 192 degrees. And that will be the small angle that you are looking for. And how do we find that? That is going to be 192 degrees minus 180 degrees. So this is going to give us 192 degrees minus 180 degrees. Okay, sorry, minus 180 degrees, and that will be 12 degrees. What that means is that if we add 12 degrees to 180 degrees, we will get 192 degrees. So we will measure 12 degrees from 180 degrees. We draw a line through it, then we indicate it as 12 degrees. So from here, when we move from 0 to 90 degrees, we have that here. From 90 degrees to 180 degrees, that will be on this line. We add 12 degrees and we now get 192 degrees to represent the bearing on this diagram. Once again, remember how we got the 12 degrees. 192 degrees minus 180 degrees. Let's move on to the next example. 332 degrees. 332 degrees. Don't forget that we are measuring the angle from the geographic north in the clockwise direction. From the geographic north in the clockwise direction. So let's measure. We begin from the geographic north. So we measure from 0 up to this point, which is 90 degrees. From 90 degrees to 180 degrees, we are still not up to 332 degrees. So we'll be going from 180 degrees to 270 degrees. It's still not up to 332 degrees. So you will move on. Don't forget that this point here is 0 degrees at the same time 360 degrees. So it means that this new angle, which is 332 degrees, will be between 270 degrees and 360 degrees. That means that you have to add some value to 270 degrees, or you have to add a value to 270 degrees in order to get 332 degrees. How do we find that value? It is 332 degrees. That value will be 332 degrees minus 270 degrees, and that is going to be 62. So it means that we have to measure 62 from 270 degrees. Remember that it is in the clockwise, we are going in the clockwise direction. So 62 from this 62 from 270 degrees. We measure 62 degrees clockwise direction. We measure 62 degrees clockwise direction from this 270 degrees. So 62 is big, so you draw something which is big enough, then you draw your line through it and you indicate here at 62 degrees. So it means that if you are measuring from the 0 in the clockwise direction, you measure to this point 90 degrees, 180 degrees, 270 degrees. We add 62 degrees to it and we have 332 degrees. It's very important that you understand how to represent compass bearings and 3-point bearings on diagrams. We will be using them a lot when we get to application of bearings. So if you understand how to draw them now, when we get there, it will be very, very easy for you to understand the things that you'll be doing. Pick more examples and try your hands on it. So you have the bearing of a point from another. We have been given 4 questions here. We will solve them one after the other. We will solve the first 2 in this video, then we solve the others in the subsequent videos. So let's look at one of the questions for this video. The bearing of point A from point B is north 70 degrees east. Illustrate this information graphically. So we are supposed to illustrate this this compass bearing on a diagram. In the previous video, we learned that this is an example of a compass bearing. The question is telling us to represent the bearing of point A from point B. It means that in this case, we are going to start from point B and we get to point A. So point B is our starting point. The bearing given us is north 70 degrees east and our ending point is point A. So in order to represent this information on a diagram, what you do is that you draw your diagram as you've been doing all along. Since this is a compass bearing, you draw the diagram with the 4 main cardinal points: north, south, west, and east. We are going to start from point A. So we will call our starting point here we are going to start from point B. Since this is the bearing of point A from point B, we are going to start from point B. So we will call our starting point here point B. Okay, what is the bearing? The bearing is north 70 degrees east. So you will measure the bearing on the diagram. We've learned in the video on compass bearing that north 70 degrees east means that start from the north, measure 70 degrees towards the east. and this is going to give us the diagram that we have here. So we start from the north, we measure 70 degrees towards the east, then we draw the line. This is our starting point, point A. Our ending point is, this is our starting point, point B. Our ending point is point A, because we are saying that question told us to represent the bearing of point A from point B on the diagram. So our starting point is point B and our ending point is point A. The bearing is north, 70 degrees east. So when you are being given a question like this represent on the diagram, the first thing you need to do is to draw the diagram. You indicate your starting point, you draw the bearing, then you indicate your ending point. Let's look at the next question for this video. The bearing of point D from point C is 105 degrees. Illustrate this information graphically. Once again, you first have to find your starting point. Our starting point is point C, since we are doing it from point C. Our ending point is point D. The bearing given to us is 105 degrees. So you draw the diagram. This is a 3-point bearing. So you are going to indicate the angles, not the 4 main cardinal points. Because it's a 3-point bearing, you indicate the angles. So 0 degrees, 90 degrees, 180 degrees, 270 degrees, then it gets back to 0 degrees or 360 degrees. Okay, we have been able to do this. Our starting point is point C, so we are going to call this point here point C. We measure the angle. The angle is 105 degrees. In the previous video, we learned how to draw 105 degrees on this diagram. The first thing you need to do is to locate where 105 degrees will fall. 105 degrees is between 90 degrees and 180 degrees, which means that it will fall in this area or this quadrant. So you ask yourself, what should you add to 90 degrees in order to get 105 degrees? And you are going to get that by subtracting 90 degrees from 105 degrees. That will be 15 degrees. So it means that you measure 15 degrees from 90 degrees, then you draw the line. So we have indicated our starting point. We have been able to draw our bearing. The ending point is point D, so you indicate it on the diagram as point D. So this is how to represent the bearing of one point from another on a diagram. The bearing of point C and point D from point A is 65 degrees and 120 degrees respectively. Illustrate this information graphically, or illustrate this information on a diagram. We have the bearing of point C and point D, and both of these bearings are taken from point A, and the angles are 65 degrees and 120 degrees respectively. And we are supposed to represent this information on a diagram. Reading the statement carefully, we can see that we have this word respectively here, and we have been given two angles, 65 degrees and 120 degrees. What this means is that the 65 degrees belongs to point C and 120 degrees belongs to point D. So the bearing of point C and point D from point A is 65 degrees and 120 degrees respectively, meaning that the bearing of point C from point A is 65 degrees and the bearing of point D from point A is 120 degrees. That is the meaning of the word respectively that has been placed after 65 degrees and 120 degrees. So from this diagram, from this question, we can see that we have two bearings here. The first one is the bearing of point C from point A, which is 65 degrees. And the second one is the bearing of point D from point A, which is 120 degrees. And we are supposed to represent these two bearings on the same diagram. So when you have this, how do you do it? Let's find out. We are going to begin with the first one, the bearing of point C from point A. We said that in order to represent this bearing, what you need to do is to find your starting point. Our starting point is point A. Our ending point is point C, and the angle is 65 degrees. So you draw your diagram. Since this is a 3-point bearing, I will draw the diagram with the angles on it. So 0 degrees, 90 degrees, 180 degrees, and 270 degrees. As you become more conversant with drawing this diagram, I'll remove the angles. For now, I use the angles so that you can see which quadrant or which area the line is going to fall. Okay, so let's begin with the first one. The bearing of point C from point A is 65 degrees. We've done quite a number of this, so I'm sure that by this time you should be able to draw for the first one. The bearing of point C from point A is 65 degrees. On this diagram, it will be illustrated with this line. So you measure 65 degrees from 0, since 65 degrees will fall between 0 and 90 degrees. So 65 degrees will fall between 0 and 90 degrees. So from 0 in the clockwise direction, you measure 65 degrees, then you draw the line. So this is our starting point, point A. We have drawn the angle on the diagram, 65 degrees. Our ending point is point C. So you indicate that on the diagram. So we are done with the first part. The bearing of point C from point A is 65 degrees. Then you move on to the second part. The bearing of point D from point A is 120 degrees. So you see that this time, our starting point is still point A. We already have point A here, so we are not going to draw another diagram. It will be on this same diagram here. Our starting point is still point A, but our ending point is point D, and our angle is 120 degrees. So it means that we are going to measure 120 degrees from this point here, which is point A, on this same diagram that we've drawn here. Okay, 120 degrees will fall between 90 degrees and 180 degrees, which means that the new line or our new bearing will be in this area or in this quadrant between 90 degrees and 180 degrees. So you ask yourself, what should we add to 90 degrees to get 120 degrees? And we are going to get that by subtracting 90 degrees from 120 degrees, and that is going to give us 30 degrees, because 30 plus 90 will give us 120. So it means that if you want to get the second bearing, that is the bearing of point D from point A, you have to measure 30 degrees from 90 degrees in the clockwise direction. So you measure 30 degrees from 90 degrees, then you draw the line. So once again, we have our starting point A. We have the angle 120 degrees drawn. Then our ending point is point D. So you see, you have been able to illustrate these two informations, the first one and the second one, on this same diagram. It's very important that you understand how to represent bearings on diagrams. We are going to use them a lot when we are solving distance bearing problems. So I will entreat you that you become conversant with representing bearings on diagrams, because when we get there, we are not going to waste a lot of time with the diagrams. You just go straight ahead to solving the questions. The bearing of point G from point O is 97 degrees. The bearing of point H from point G is 250 degrees. Illustrate this information graphically. So you have been given two bearings here. The first one is the bearing of point G from point O. That is the first one. And the second one is the bearing of point H from point G. So you will solve, or you represent each one of them on the same diagram. Let's tackle the first part. The bearing of point G from point O is 97 degrees. So you draw our diagram. The bearing of point G from point O, it means that our starting point is point O. The angle we are supposed to measure is 97 degrees. We know that 97 degrees will fall between 90 degrees and 180 degrees. So it means that we are going to measure from 90 degrees in the clockwise direction. Now, what do we add to 90 degrees in order to get 97 degrees? The answer is 7. So you will measure 7 in the clockwise direction from 90. So you measure 7 in the clockwise direction, then we draw the line. So our starting point is O. We have indicated that. We have also drawn the angle, which is 97 degrees. The ending point is point G. So you indicate that point G. So we are done with the first part. The bearing of point G from point O is 97 degrees. You have been able to represent that. Let's move on to the second part. The bearing of point H from point G. The bearing of point H from point G, and that is 250 degrees. So it means that our starting point is point G. That is the point G that we have been able to indicate here, or that's the point G that we have indicated here. So what do? We draw this diagram here on point G. We draw the horizontal line and the vertical line, and we indicate the angles here on point G because you are going to take the bearing from point G. I hope that is clear. The first part, the ending point was point G. The second part, the starting point is on point G. Because the starting point is on point G, we are going to draw this diagram here with the angles indicated on it like this, so that we can take the new bearing from point G. So the starting point is point G. The angle is 150 degrees. So we know that 150 degrees is between 180 degrees and 270 degrees. So we measure from 180 degrees in the clockwise direction. So you ask yourself, what should we add to 180 degrees in order to get 250 degrees? The answer will be 250 degrees minus 180 degrees, which is 70 degrees. If you add 70 degrees to 180 degrees, you're going to get 250 degrees. So you draw the angle. We have drawn the angle 70 degrees. We know the starting point, which is G. We have been able to indicate it. The ending point is point H. So you indicate that one also, point H, on the diagram. So you see that on this same diagram, we have been able to indicate the first bearing and the second bearing. As I said, drawing diagrams for bearings is very, very important, because when we get to distance bearing problems, we are going to draw a lot of diagrams for the question that has been given to us. So it's important that you understand how to draw the diagrams now. Back bearing. If the bearing of y from x is theta, then the bearing of x from y is the back bearing. So just as the name implies, if the bearing of y from x is theta, the back bearing is the bearing of, if the bearing of y from x is theta, then the back bearing is the bearing of x from y. So on this diagram, you can see that theta here represents the bearing of y from x. So this is the bearing of y from x as indicated on the diagram. The back bearing is the bearing of x from y. So the angle that will be created here. So you see the arc that I've drawn here represents the back bearing. So if theta, which is the bearing of x, the bearing of y from x, then the back bearing is the bearing of x from y. I hope that makes sense. The bearing of y from x is theta. The back bearing is the bearing of x from y. How do we find the back bearing for a given bearing or a given angle? If the bearing of y from x is theta, then the back bearing is given by theta plus 180 if theta is between 0 degrees and 180 degrees, and theta minus 180 if theta is greater than 180 degrees but less than or equal to 360 degrees. What does this mean? This means that if the angle given to you is between 0 degrees and 180 degrees, then the back bearing is that angle plus 180 degrees. So if the angle is less than 180 degrees, the angle given to you is less than or equal to 180 degrees. In order to find the back bearing, add 180 degrees to the angle. If the angle given to you is greater than 180 degrees but less than or equal to 360 degrees, subtract 180 degrees from the angle in order to get the back bearing. So it's pretty simple. If the angle given to you is less than 180 degrees, add 180 degrees to it in order to get the back bearing. If the angle given to you is greater than 180 degrees, subtract 180 degrees from it to get the back bearing. So let's pick some questions and see how this is done. We have 4 questions here. We will solve the first one in this video, then the others in the subsequent videos. So let's pick the first question. If the bearing of A from B is 65 degrees, find the bearing of B from A. We know that the bearing of B from A is the back bearing of A from B. So all the question is telling us to do is to find the back bearing. The bearing of A from B is 65 degrees. The back bearing will be the bearing of B from A. So the question is telling us to find the back bearing. As we saw in the previous 2 slides, we said that if the angle given to you is less than 180 degrees, or the angle is between 0 degrees and 180 degrees, all you need to do is to add 180 degrees to the angle in order to find the back bearing. Here the angle given to us is less than 180 degrees. So to find the back bearing, all we have to do is to add 180 degrees to 65 degrees. So 65 degrees plus 180 degrees, and we get our answer, which is 245 degrees. So the back bearing is 245 degrees. It's pretty simple. But I'm going to teach you how to use your diagram to find the back bearing. That is very, very important. You've learned the quick way of finding the back bearing. We just added 180 degrees to 65 degrees and you have been able to find the back bearing. How do you find it from the diagram? The first thing you need to do is to first draw the bearing that has been given to you. The bearing of A from B is 65 degrees, so we draw it. I suppose that I will assume that by this time you've drawn a lot of bearings on diagrams, so you are conversant with this. So I will not go ahead and explain how to draw this because you have done a lot of them, so you should be able to draw bearings on diagrams by now. So we are starting from B and we will end at A, and it's 65 degrees. To find the back bearing, that's the bearing of B from A, we will draw our diagram on A like this. So you can see clearly from here that the bearing of B from A will be this angle. You will measure from the 0 up to this point. But we know that from this point here up to this point here is 180 degrees. So the most important thing we need to do is to find this small angle here, or to find this angle here. Now, how do we find that angle? We are going to apply a little bit of plane geometry here. We learned from plane geometry that if you have parallel lines with transversals crossing through them, you are going to create alternate angles, corresponding angles, and co-interior angles. We will be using alternate angles here. So this is what I'm going to do. If we extend this line and extend this line, you will see that this line here and this line here are parallel lines, and line BA or line AB is a transversal. When that happens, we can see that this angle here, the angle that will be created here, and the angle that is already here are alternate angles, and alternate angles are equal. So if here is 65 degrees, here is also going to be 65 degrees. So we have been able to find this angle here. The bearing of B from A, which is also known as the back bearing, the bearing of B from A, which is also known as the back bearing, we said that it is the angle you get by measuring from A through to this point here. We have now found this area to be 65 degrees. We know that from here to this point is 180 degrees. So if you want the back bearing, what do? We just add 65 degrees to 180 degrees. So the back bearing is 65 degrees plus 180 degrees, and that gives us 245 degrees. Remember, it is the same as what we had on our calculator. So I've shown you how to use your calculator to do it. If the angle is less than 180 degrees, just add 180 degrees to it to find the back bearing. I've also shown you how to find the back bearing on the diagram. That is also very, very important. Find the bearing of y from x if the bearing of x from y is 118 degrees. So the bearing of y from x is the back bearing of x from y. So all the question is telling us to do is to find the back bearing. We learned in the previous video that to find the back bearing, if the bearing given to you is between 0 degrees and 180 degrees, add 180 degrees to it in order to get the back bearing. Here the angle we have is 118 degrees. It's between 0 degrees and 180 degrees. So in order to find the back bearing, we add 180 degrees to 118 degrees. So we have 118 degrees plus 180 degrees, and this will give us 298 degrees. So using the formula, the back bearing is 298 degrees. Let's learn how to use the diagram to find the back bearing. We've learned how to use the formula to do it. Now let's go on to the diagram. In order to use the diagram, draw the diagram for the bearing given to you. The bearing given to us is x from y and it's 118 degrees. If you draw the diagram, this is what you are going to get. As we learned in the previous video on 3-point bearings, if you draw it very well, you will see that the angle here is 28 degrees. If you want to understand why we got 28 degrees here, watch the video on 3-point bearings. You understand why this place is 28 degrees. Now the bearing of y from x, you draw your diagram here. Then we know that the bearing of y from x, if you continue on this line and you continue on this line from plane geometry, we can see that this line here and this line here will be parallel lines. And if they are parallel lines, then it means that line xy is a transversal. So this angle here is 28 degrees. It is alternating with this angle here. So this angle here is also going to be 28 degrees. In the video on angle properties on parallel lines under plane geometry, I explained this property into detail. So if you watch that video too, you are going to understand why this angle here is 28 degrees. Now the bearing of y from x is going to be from this line here, clockwise direction, up to this line. But we know that from this point here, which is the 0 point, up to this point is 270 degrees. So in order to get the bearing, we just have to add 270 degrees to 28 degrees. And we are going to get 270 degrees plus 28 degrees. And that is going to be 298 degrees. So the back bearing is 298 degrees. It is the same as what we had on our calculator. On the calculator, we use the formula, and here we use the diagram. So in both cases, you are going to get the same thing. Once again, it's very, very important that you learn how to use the diagram to do it. Okay, let's move on to the next part, or the next question. The bearing of M from N is 200 degrees. Find the bearing of N from M. So once again, we are being told to find the back bearing. With the formula, we said that if the angle is less than 180 degrees, add 180 degrees to it. If the angle is more than 180 degrees, subtract 180 degrees to it, from it, sorry. So here we have 200 degrees. So what we are going to do is that we are going to subtract 180 degrees to it. Since 200 degrees is greater than 180 degrees, we are going to subtract 180 degrees from it. So we have 200 degrees minus 180 degrees, and that is going to give us 20 degrees. So from using the formula, we have found the back bearing to be 20 degrees. Let's learn how to use the diagram to find it. So on the diagram, you draw your point here, the bearing of M from N. So with the bearing of M from N, this is the diagram you are going to obtain. If you want to understand why here is 20 degrees, watch the video on 3-point bearings. This was explained there, why this place will be 20 degrees. Okay, so in order to find the back bearing, you draw another diagram, you draw another line here, a horizontal and a vertical line here. So the back bearing, that's the bearing of N from M, will be this angle that is created here. So what you have to do is to find the angle that will be created here. Okay, we know that if we extend this line here and we extend this line here, these two lines are parallel lines. So line MN will be a transversal. And if it's a transversal, from the angle properties of parallel lines, we know that the angle created here and the angle created here will be alternating angles. Alternating angles are equal. So if here is 20 degrees, this side here is also going to be 20 degrees. So it means that the angle that we will find here is going to be 20 degrees. The bearing of N from M will be measured from this line straight onto this line here. So it means that the bearing will give us 20 degrees. The bearing of M from N, the bearing of N from M, which is the back bearing, will give us 20 degrees. So we can say that the bearing of N from M is 20 degrees. And that is exactly what we found on our calculator using the formula. Let's move on to the last question for this video. The bearing of P from Q is 275 degrees. Find the bearing of Q from P. So we are looking at the back bearing. The formula says that if the angle given to you is greater than 180 degrees, subtract 180 degrees from it. 275 is greater than 180 degrees. So to find the back bearing, is going to be 275 minus 180, and that will give us 95 degrees. So with the formula, we have been able to find the back bearing as 95 degrees. Let's learn how to use the diagram to find it. So what you have to do is to draw the bearing, the diagram for the bearing that has been given to you. That is P from Q. If you draw P from Q, this is the diagram that you are going to have. So P from Q will give us this diagram. As I said, if you want to understand why here is 5 degrees, watch the video on 3-point bearings. We explained that into details there. Okay, so we want to find the back bearing. So I'll draw the diagram on P here. Then we will find the back bearing. And you can see clearly from here that the back bearing will be measured from this line straight onto this line. But we know that from here to this side here, or to this point here, is 90 degrees. So it's 90 degrees. So we need to find a small angle and add it to 90 degrees in order to get the back bearing. We know from plane geometry that if we extend this line here and we extend this line here, these two lines will be parallel lines. This line and this line are parallel lines. So if here is 5 degrees, it will be alternating with this angle here, which is also 5 degrees, because alternating angles are equal. So in order to find the back bearing, it's going to be from this line here straight onto this line, which is 90 degrees plus 5 degrees. So it's going to be 90 degrees plus 5 degrees, which will give us 95 degrees as the back bearing. So you see that using the formula and using the diagram, we have been able to find the back bearing as 95 degrees. So in each case, we solve the question using the formula and using the diagram. It's okay if you know how to use the formula to find the back bearing, but it's also very, very important that you learn how to use the diagram to find the back bearing, because you are going to apply it a lot in our studies on application of bearings. The bearing of X from Y is 70 degrees and the bearing of Z from Y is 150 degrees. Y is equidistant from X and Z. Draw a diagram for the information above. From your diagram, find the bearing of Z from X. So let's solve this question. The bearing of X from Y is 70 degrees and the bearing of Z from Y is 150 degrees. Y is equidistant from X and Z. Draw a diagram for the information above. We have been drawing diagrams for bearings since we started our studies on bearings, and we are going to use what we have been able to learn to draw the diagram for this question here. So we will take the first part of the question. The bearing of x from y is 70 degrees. We know that when you have this bearing, in order to draw it on a diagram, you first need our starting point. The starting point is y because it's x from y. The ending point is z and the angle is 70 degrees. So to begin the whole thing, we draw our x and y plane here. We know that on our x and y plane, this side here is 0 degrees, here is 90 degrees, here is 180 degrees. Okay, here is 180 degrees, and here is 270 degrees. 270 degrees. Okay, now our starting point is y, our ending point is x, and the angle is 70 degrees. So we measure 70 degrees from 0 in the clockwise direction, and that will give us this. We will draw our line, then we indicate x here as the ending point. Let's go on to the second part. And the bearing of z from y is 150 degrees. So once again, our starting point is y, ending point is z, and the angle is 150 degrees. So we have the starting point here, so there's no need drawing another xy plane. What we are looking for is the angle, which is 150 degrees. 150 degrees is between 90 degrees and 180 degrees. Now, what do we add to 90 degrees in order to get 150? It's 60. 60 plus 90 will give us 150. So it means that we have to measure 60 degrees from 90 degrees in the clockwise direction. So we measure 60 degrees, then you draw our line through it, as we can see here. So you measure 60 degrees, you draw the line, then you indicate the ending point, which is z. So the bearing of x from y is 70 degrees and the bearing of z from y is 150 degrees, has been illustrated on this diagram here. I'm going to clean all the ink since we are done with that now. The question goes on to say that y is equidistant from x and z. Y is equidistant from x and z. What this statement means is that moving from y to x is the same as moving from y to z. That's the meaning. Y is equidistant from x and z. What this means is that moving from y to x is the same as moving from y to z. So if I represent here with a bar, I'm going to draw another bar here to show that from y to x is the same as from y to z. So you have been able to represent this information here on the diagram. So we have answered the first part of the question. The second part is that from the diagram, find the bearing of z from x. From the diagram, find the bearing of z from x. Now, in order to find the bearing of z from x, you have to join z to x as shown here. In order to find the bearing of z from x, we have to join point z to point x. Now, how do we find the bearing of z from x? How do we find the bearing of z from x? As we saw in the previous video, in order to find the bearing of z from x, we have to connect x to z as we've done here. Then we will draw our little x and y plane on x because that is our starting point. We are finding the bearing of z from x. So we have to draw the x and y plane on x. Okay, so the bearing of z from x will be measured from, if you remember our 3-point bearing, we see that we measure from the geographic north, which is this side here, in the clockwise direction. So it will be measured from this line straight up to the line connecting X to Z. So our bearing of Z from X will be measured from this point onto the line connecting X to Z. But we know that from this point here to this point here is 180 degrees. So the only thing we really need to find is this angle here. If you're able to find that angle and add it to 180 degrees, we can now find the bearing of Z from X. So all our work is going to be towards finding this angle here, so that we can add it to 180 degrees in order to get the bearing of Z from X. Now let's start. We know from we know that this triangle XYZ is an isosceles triangle, because isosceles triangle has two of its sides being equal. So triangle XYZ is isosceles because YX and YZ are the same. We also know that if this side here is 70 degrees, then this side here will be 20 degrees, because here is 0 degrees and here is 90 degrees. So if here is 70 degrees, then this side here will be 20 degrees. So we can say that from the diagram, angle XYZ, which is this angle, is 80 degrees. 20 degrees plus 60 degrees will give us 80 degrees. If you watch the video on Introduction to Plane Geometry, I explained how to name angle there, so you understand why this angle is called angle XYZ. So we have this to be 80 degrees. As we said previously, triangle XYZ is an isosceles triangle. So angle YZX and angle YXZ are the same. So if here is N, here is also going to be N. If you want to understand why angle YXZ is equal to angle why angle YZX is equal to angle YXZ, it has been explained in the video on angle properties of triangles. If you watch that video, you will understand the properties of isosceles triangles, and you will see that the angle created here and the angle created here are the same. So if I call this one angle N, this one is also going to be angle N. From the properties of triangles, we know that the sum of the interior angles of a triangle is equal to 180 degrees. So if we add everything in this triangle XYZ, we are going to get 180 degrees. So N plus 80 degrees will give us 180 degrees. If you simplify this, you will see that N will give us 50 degrees. So we have been able to find one of the angles here, 50 degrees. Let's move on. Our main interest is finding this angle here. Our main interest is in finding this small angle here, so that we can add it to 180 degrees to get the bearing of Z from X. We have been able to find here this angle here to be 50 degrees. Now look at something. If we extend this line, I'm going to do that again. I'm going to clean it and do it again. If we extend this line, and we extend this line, I hope you get the picture. So we extend this line and we extend this line. You will see that these two lines here are parallel lines. So this line here, this is what I mean. This line here and this line here are parallel lines. And if they are parallel lines, then line YX becomes the transversal. If line YX is the transversal, the angle created here, which is 20 degrees, and the angle that will be formed here will be alternating angles. We know from plane geometry that alternating angles are equal. Once again, I explained this property of alternating angles in the angle properties of parallel lines. So if you watch that video too, you will get more knowledge about alternating angles. So because alternating angles are equal, if here is 20 degrees, this side here is also going to be 20 degrees. Now look at something. We have been able to find this side here to be 20 degrees. We have been able to find this side here to be 50 degrees. We know that from this point to this point, the total angles here is 90 degrees. From this point here, which is the 270 degrees point, to this point here, which is the 180 degrees point, the angles between them, between 270 degrees and 180 degrees, the angle there is 90 degrees. We have found here to be 20 degrees, here to be 50 degrees. So what is left will be for this space here, and that will give us 20 degrees, because 90 degrees minus 20 degrees minus 50 degrees will give us 20 degrees. So if you add all this, you see that the total angle there will be 90 degrees. So we have been able to find this angle here, which is 20 degrees. That was what we were looking for. We said that as soon as we get that angle, to find the bearing of z from x, it is going to be this. From this side here, up onto the line connecting x to z. And we have been able to find this angle here to be 20 degrees. We know that from the zero line to this side here is 180 degrees. So we just add 180 degrees to 20 degrees. So we can say that from the diagram, the bearing of z from x is 180 degrees plus 20 degrees. And what is 180 degrees plus 20 degrees? We are going to get 200 degrees. So we can say that from this diagram, the bearing of z from x is 200 degrees. The bearing of A from B is 129 degrees, and the bearing of C from B is 225 degrees. If B is equidistant from A and C, A, represent this information on a diagram. B, from your diagram, find the bearing of C from A. Okay, so let's tackle the first part of the question, which is to draw a diagram for the information that has been given to us. So the bearing of A from B is 129 degrees. This means that our starting point is B, the ending point is A, and the angle given to us is 129. That is for the first part. So we are going to start with that. So as usual, I'll draw my x and y plane here. Don't forget that this side here is the 0 degrees. Sorry. Here is 90 degrees. Here is 180 degrees. Sorry. 180 degrees. And here is 270 degrees. 270 degrees. Okay. Once again, remember that in our examination, you don't necessarily have to indicate these angles. I just write them so that I'll be able to explain it to you very well. Okay, so let's tackle the first part. The bearing of A from B. So we are starting from B. And the bearing of A from B is 129 degrees. So 129 degrees will be between 90 degrees and 180 degrees. So you ask yourself, what should you add to 90 degrees in order to get 129? And that will be 39. So you measure 39 from 90 degrees in the clockwise direction, then you draw your line. The starting point is B and the ending point is A. So you've solved the first part. The second part says that the bearing of C from B is 225 degrees. The bearing of C from B. Once again, we are taking the bearing from B, so we are still going to take the bearing from this point. 225 degrees is going to be between 180 degrees and 270 degrees. So you ask yourself, what should you add to 180 degrees in order to get 225 degrees? And that is 45 degrees. If you want to understand how we got this 39 degrees and 45 degrees, if you still don't understand it by now, rewatch the video on 3-point bearings. I explained that into details there. So here will be 45 degrees, here is 39 degrees. The second part is the bearing of C from B. So it means that the starting point is B and the ending point is C. The question goes on to say that B is equidistant from A and C. What it means is that moving from B to A is the same as moving from B to C, or the distance BA is the same as the distance BC. So if I draw a line here, I can indicate another one here to show that BC is the same as BA. Now, there is something that you need to take note when drawing the diagrams. Always when drawing the diagrams, make sure that the diagram represents the information that has been given to you, or draw the diagram very, very well. Now, this is what I mean. We know that this angle that will be created here is 39 degrees. We know that from this point here, which is the 90 degrees point, to this point here, which is the 180 degrees point, the total angles there will be 90 degrees. So we know that 39 is close to half of 90 degrees. So draw it in such a way that it will cover about half or something close to half of the 90 degrees. Don't draw it so small. Now this is what I mean. You know that this is our 39 degrees. That is what we've drawn. Don't draw 39 degrees like this and indicate this small angle here as 39 degrees. When you do that, you are going to have a wrong diagram and it's going to affect your answer. It will be difficult to get the answer correct. So always when you are drawing the diagram, make sure that the diagram represents the information that has been given to you. Another thing on this diagram too that you have to notice that you see the question says that the distance from B to C and the distance from B to A are the same. So make sure that B to C and B to A are the same. Don't draw one such that don't draw it in such a way that one will become longer than the other. When you do that, you see that when you are presenting your final answer, you'll be experiencing some problems. So always make sure that the diagram that you are going to draw represents the information that has been given to you. For example, here, we know that this angle is 45 degrees. We know that between 180 degrees and 270 degrees, the total angle there will be 90 degrees. 45 degrees is half of 90 degrees. So make sure that the angle, which is 45 degrees, covers about half of it. Don't draw it too big or too small. Now, you see that for 45 degrees, make sure that don't draw 45 degrees like this. Now you can see clearly from here that if you draw this as 45 degrees, it's wrong. And when you draw it wrongly, it's going to affect the answer that you have. Okay, so you have been able to illustrate this information here on the diagram. So that is the first part of our question. The second part of our question says that from the diagram, we should find the bearing of C from A. In order to find the bearing of C from A, what we have to do is that we join A to C as we have done in this diagram here. So let's go on and find the bearing of C from A. Because we are looking for the bearing of C from A is going to be our starting point. So I'll draw the little X and Y plane that you have been doing on point A. Now the bearing of C from A is going to be taken from this line here, which is the 0 line, up onto the line joining A to C. So the bearing of C from A will be taken from this point here up to this point. Now we know that from here to this side here is 180 degrees. So all we need to do is to find this other angle here and we add it to 180 degrees. So if you're able to find this angle here, we will add it to 180 degrees to get the bearing of C from A. So all the work that we are going to do in this video will be towards finding that angle. Okay, we know that from this point here, which is the 90-degree point, to this point here, which is the 180-degree point, the angles there will be 90 degrees. So if here is 39 degrees, the angle here will be 90 degrees minus 39 degrees, which is 51 degrees. So this angle here becomes 51 degrees as indicated. Now from there we can say that angle ABC is equal to 45 degrees plus 51 degrees, and that will give us 96 degrees. We can see from the diagram that triangle ABC is an isosceles triangle. We said that isosceles triangle has two sides being equal. So because triangle line BC and line AC are the same, the triangle ABC is an isosceles triangle. From the angle properties of triangles, we said that for isosceles triangles, the angles formed at the basis of the two lines that are equal are also equal. So here, the angle BAC and angle BCA are also equal because the triangle ABC is an isosceles triangle. So if I call this angle here, which is angle BCA, as X, angle BAC will also be X. We know that from the properties of triangles, if you add all the angles in a triangle, you should get 180 degrees. So if I add all the angles in this triangle, that is 45 degrees plus 51 degrees, which is 96 degrees. If I add it to this X and this X here, I must get 180 degrees. When you simplify this, you are going to get X to be 42 degrees. So here is 42 degrees and here is also 42 degrees. This value that we found is very important. We are going to use it in the next slide. Okay, so let's go on to find our angle. We are finding the bearing of C from A. So as usual, we will draw this diagram here on point A. Okay, we know that the bearing of C from A will be given by this angle here. As we've said, we know that from this point to this point here is 180 degrees. So all we are interested in is finding this angle. When we're able to find it and we add it to 180 degrees, we will be able to find the bearing of C from A. Now, how do we find that angle? Look at something here. You can see from this diagram that if we extend this line here, if we extend it and we extend this line to, oh sorry, I'm going to draw the line again so that you get it very well. Okay, so this is what I mean. If we extend the line above and we extend this line to, you can see that these two lines are parallel lines. They are never going to meet. So this line and this line are parallel lines. If they are parallel lines, then line AB is a transversal. From the angle properties of parallel lines, you can see clearly that this angle here, the 39 degrees, and the angle here are alternating angles. Alternating angles are equal. So if here is 39 degrees, the angle that will be created here is also going to be 39 degrees. Once again, in the video on angle properties of parallel lines under plane geometry, I explained the property of alternate angles. So if you don't understand this very well, you might want to check that video and learn more about alternate angles. So the angle here, which is 39 degrees, is alternating with this angle here. So this side is also going to be 39 degrees. Now look at something here. We just found out from the previous slide that this whole angle here is 42 degrees. Now we have found this part here to be 39 degrees. So if this whole angle here is 42 degrees, it's 42 degrees, so you can see this one clear. The whole thing is 42 degrees, and we have been able to find this side here to be 39 degrees. Now, what will be this small angle here? It's going to be 42 degrees minus 39 degrees. So this small angle here is going to be 42 degrees minus 39 degrees, and that is going to give us 3 degrees. So it means that the small angle here is 3 degrees because the whole thing is 42 degrees, and we have been able to find this side here as 39 degrees. So the small angle here will be 3 degrees. Now look at another thing too. Don't forget that this is the 180 degree point. Okay, so this is the 180 degrees point, and this side here is the 270 degrees point. Okay, so this side here is also the 270 degrees point. Now between 180 degrees and 270 degrees is 90 degrees, and this small part here is 3 degrees. So what is this bigger portion here? It's going to be 90 degrees minus 3 degrees, and that is going to give us 87 degrees. So you see that we have been able to manipulate the diagram in order to get the angle here which we were interested in, and now we have been able to find it. That angle is 87 degrees. As soon as we find that angle, all we need to do is to add it to 180 degrees in order to get the bearing of C from A, because as we said, the bearing of C from A will be measured from this line, which is the 0 line, in the clockwise direction up onto the line joining A to C. From this side to this side here is 180 degrees. The angle left here, which is this, has also been found as 87 degrees. So we add 180 degrees to 87 degrees to get the bearing of C from A. And the bearing of C from A has been found as 267 degrees. So we have been able to use our diagram to find the bearing of C from A.